Hi, so for this video we'll be evaluating this infinite series 1 minus 2 cubed over 1 factorial plus 3 cubed over 2 factorial minus 4 cubed over 3 factorial and many other terms. So the first thing to notice here is that this is not an arithmetic progression and it's not a geometric progression. Okay, so let's see what we will do for this. The first thing I'm going to do is to write this series in some form of standard expression. So I'm going to write this as the summation of, so let's see what we have here. The first thing to note is that we have alternating plus and minus symbols, and we can generate this easily if I say negative 1 to the power n. Another thing to note here is that the numerator is 1 unit bigger than the denominator, so we have 2, 1, 3, 2, 4, 3. Okay, so just take this off quickly here. So I will write that as n plus 1 cubed divided by n factorial. As you can see here, n plus 1 is on top and n is the denominator here at the bottom. And I should go from 0. Of course, this is going all the way to infinity. So I'll go from n equals 0 to infinity. So this thing right here generates the infinite series that we have up here. Now, something very nice here is that n plus 1 cubed can be written as n into n minus 1 into n minus 2 plus 6n into n minus 1 plus 7n plus 1. So I'm going to substitute for n plus 1 cubed, I'm going to substitute this here. So let's go ahead and do that. So I'll write this as summation from n equals 0 to infinity of negative 1 to the power n. So let's write this here, n into n minus 1, n minus 2, plus 6n into n minus 1, plus, and you'll see shortly why I'm doing this. So I divide all this by n factorial. Okay, so let's proceed down here. So I'm going to write this as the summation from n equals 0 to infinity. I'm going to break this down as negative 1 to the power n. So I'll have this here now, n into n minus 1, n minus 2, divided by n factorial, plus the summation from n equals 0 to infinity of negative 1 to the power n of 6n into n minus 1 divided by n factorial, right? Plus the summation from n equals 0 to infinity of, so that's 7. Okay, I have negative 1 to the power n first, and then 7n over n factorial. And finally, I have negative 1 to the power n over n factorial, still from n equals 0 to infinity. Now, why am I doing this? So you may recall that n factorial is n into n minus 1, n minus 2, n minus 3, and so on. Of course, I choose to put a factorial anywhere as I proceed with this expansion. So using that, I can rewrite this in a shorter way. So let's proceed down here. So we have the summation of negative, just write this a little bit bigger. So the summation from, okay, I'll write that. So I have negative 1 to the power n. So if I write this as n into n minus 1, n minus 2, I'll just have n minus 2 factorial at the bottom here, and on top here I'll just remain with I'll just go up to n minus 3 factorial because I want to cancel out this with the numerator. So I'll just have 1 as my numerator here. So there we go. And of course now I have to begin from n equals 3. Okay, to infinity, plus I'll do the same here. So summation from n equals, I'll write that later, to infinity. So I have negative 1 to the power. Can just put that here, because I'm going to cancel out most of the terms. I'll just have, so this, I'll write this as n into n minus 1, n minus 2 factorial. So this and this will cancel with this and this. Okay, so you can see that easily. So down here, I'll have n minus 2 factorial. Now, of course, there's a 6. Let me just put that out here real quick, and then let me just have that 7 also out, and then this is the same as n into n minus 1 factorial. So the n cancels with this, and for this I'll have, okay, so I'll have negative 1 to the power n, and I'll have n minus 1 factorial. So this goes from n equals 2, so this is from n equals 1 to infinity. And okay, finally we have this here, summation from n equals to 0 to infinity of negative 1 to the power n over n factorial. So the next thing I'm going to do, as you can see now, I have n equals 3, n equals 2, and n equals to 1. And my original series is starting from n equals to 0. So let's try to scale that down to start from 0. So for the first one here, I'm going to let m to be equal to n minus 3. So I'll write this as the summation from m equals to 0, from m equals to 0 to infinity of negative 1 to the power. So if you just make m the subject of the formula, n the subject of the formula, sorry, that's going to be m plus 3 divided by m factorial plus 6 times the summation from n equals, that's going to be, of course, for this, I'll have m equals n minus 2. So this is m equals to 0 to infinity of negative 1 to the power m plus 2. What's that going to be? Divided by n minus, no, not that, that's m factorial plus 7 times the summation from m equals to 0 to infinity of negative 1. So if we have m as n minus 1, so this is going to be m plus 1 divided by m factorial. For this, we'll have the summation from m equals to 0, so I'll just have m equals to n anyways, so to infinity of negative 1 to the power m over m factorial. So let's see what this is. Negative 1 to the power m times negative 1 to the power 3. So as you can see, this is a negative 1, so just take this off quickly here. Nice. So this is negative of from m equals to 0 to infinity of negative 1 to the power m divided by m factorial. So this is going to be negative 1 to the power m times negative 1 squared, which this is positive. So just have a positive sign here. 6 times the summation from m equals to 0 to infinity of negative 1 to the power m over m factorial. So I'll have plus 7 times the summation from, so as you can see, this is negative 1 to the power m plus 1, which is negative 1 to the power m, and negative 1 to the power 1, which is a negative. So I'll have a negative right here. So there we go. From m equals to 0 to infinity of negative 1 to the power m over m factorial. There's 7 there. Okay, plus the summation from m equals to 0 to infinity of negative 1 to the power m over m factorial. So if you can see this, 6 minus 7 is negative 1. So this is negative 1. And then this here is positive 1. So all this is going to be a 0. So I just end up with negative summation from m equals to 0 to infinity of negative 1 to the power m divided by m factorial. And of course, by definition, we know that the summation, just use another color here. So by definition, we know that the summation of, say, x to the power n over n factorial is the exponent of x. So this right here is going to be exponent of negative 1, exponent of negative 1 with this negative here, which is negative 1 over e, and that's our answer. So thanks for watching this video. If you find it helpful, give it a thumbs up. If you haven't subscribed to the channel, go ahead and do that. I'll see you in the next video. Bye.